Something really big is happening in AI right now. For the longest time, the rule was simple: bigger is better. But a few recent breakthroughs from places like Meta, Harvard, and DeepSeek are proving that's just not true anymore. We're entering a whole new era, one where clever design is starting to beat brute force. Let's get into it. For years, the mantra in AI was just scale up. More parameters, more data, that's how you get a smarter AI. But that's changing, and it's changing fast. The new idea, the one we're really going to dig into, is that the scaffolding, the entire system you build around the model, is what really unlocks its power, maybe even more than the size of the model itself. So to prove this point, we're going to look at 3 huge pieces of evidence that just dropped. First up, we'll explore the scaffolding shift with an incredible new agent from Meta and Harvard. Then we'll see how tiny models are starting to punch way above their weight class. And finally, we're going to decode a mysterious and frankly massive info dump from DeepSeek. All right, let's dive into our first piece of evidence, the Confucius Code Agent. Now, this thing isn't just another coding bot. No, it's built on a philosophy that's a direct challenge to the old way of thinking. So, what exactly is this scaffolding we keep talking about? Well, think of it as everything that's not the core AI model. It's the memory systems, the strategies for using tools, the entire operational framework that the AI lives in. The team behind Confucius basically argues that for an AI to survive in the real world, the scaffolding isn't just a nice-to-have, it's everything. So here's how Confucius actually pulls this off. It's got 3 key breakthroughs. First, it has this brilliant memory system that stops the AI from getting amnesia when it's like 100 steps deep into a task. Second, it literally takes notes for itself, just like a human engineer would, to learn a code base over time. And third, it uses its tools in a way more structured, disciplined way. You see, these aren't just minor tweaks. They are fundamental design choices, and they have a huge impact. And all of this smart system design leads to a result that is, well, it's honestly stunning. It's a result that perfectly captures our whole theme today. Because when they put this system to the test on a really tough coding benchmark, something pretty remarkable happened. And this is where it all comes together. Just look at this chart. An AI agent using a weaker model, Claude 4.5 Sonnet, but wrapped in that powerful Confucius scaffold, actually beat the much stronger Claude 4.5 Opus model that was running in a weaker system. That is a huge deal. It's proof. A smarter system can make a smaller model punch way, way above its weight. Now, let's move on to our second piece of evidence. This one really reinforces that same idea, but it comes at it from a totally different angle: the model's actual architecture. This is where we get to see just how powerful smart design can be. Okay, so meet Falcon H1R7B. In an age of AI models with hundreds of billions or even trillions of parameters, this one has just 7 billion. I mean, in today's AI world, that is tiny. But you should not let that size fool you. Its performance is anything but small. Right, so despite being so small, this model pulls off an incredible 88.1% on a really difficult math benchmark. It's going toe-to-toe with models that are many, many times its size. So what's its secret? How is this possible? It all comes down to just really, really clever design. It uses a hybrid architecture that gives it this enormous memory window, and it's trained in a way that rewards being verifiably correct, not just sounding plausible. It's this beautiful combination of efficiency and precision that lets it compete with the heavyweight. So the main takeaway here is really important. When you get the architecture and the training pipeline just right, that old advantage of just having more parameters starts to shrink a lot. A smarter, smaller model really can compete with the giants. And finally, let's turn to our third piece of evidence. Now, this one was the quietest move of the bunch, but it might just be the most significant. It signals a major strategic shift from one of the world's top AI labs. Out of nowhere, with absolutely no announcement, DeepSeek updated their landmark paper about their R1 model. And it didn't just get a little longer. It went from a pretty standard 22-page paper to a colossal 86-page technical manual. This wasn't just an update. It was a secret dump of their entire playbook. And what they revealed was basically a treasure trove. Their full, detailed 3-stage training process, exhaustive new benchmarks. The appendices are so detailed, they're basically an instruction manual for anyone who wants to replicate their work. And they even included their failed experiments. That level of transparency is almost unheard of. This quiet but massive info dump has the entire AI community buzzing about one question: why? Why would a company give away all its secrets like this? The most popular theory is that you only do something like this when your old tech is about to be made obsolete by something way, way better. It feels like they're clearing the decks before a major new model release. So the crucial point from all three of these stories, from the Confucius Agent scaffold to Falcon's architecture to DeepSeek's open playbook, is that we've clearly entered a new phase. The race is no longer just about who can build the biggest thing. It's about intelligent, sophisticated, and clever system engineering. And this leaves us with a final, really provocative thought. If the competitive advantage is shifting away from building bigger models and towards architecting smarter systems, then the entire landscape of who wins in AI could be completely upended. The next big breakthrough might not come from the team with the most computers, but from the team with the most brilliant system